Hey guys, welcome back. We're in day 9 still, and we're going to do the examples from day 9. Now, with day 9, we have two formulas that we've learned. Speed of light equals the wavelength times frequency. Right? So we got wavelength, frequency. Right, and this is speed. It's a constant. Also, we have energy. Equals a constant. That's H. Times the frequency. And rearranging these, right, if we do C equals nu over lambda, so C equals lambda over, there we go. C divided by lambda equals nu. Finally got it out. And so we can do E equals HC over lambda. We can do it that way as well. So those are our formulas, or tools. And let's look at this. And so the first one, all right, I'm looking. The verb is calculate. So we got brilliant red colors seen in fireworks are due to the emission of light with wavelengths around 650 nanometers when strontium straws are heated. Calculate the frequency, calculating frequency and energy of the light of 650. So I'm going to go C equals lambda nu. And we know what C is, always, 650, and we're looking for the frequency. So again, nu is C divided by the wavelength equals nu. All right, so C is 3.00 times 10 to the 8th meters per second. And notice I'm in meters here and are nanometers, right? And so 650 nanometers is the same thing as 650 times 10 to the negative 9 meters, right? 650 nanometers. Now, I'm just going to throw that in on the bottom. 650 times 10 to the negative 9 meters. And the units will work out to be frequency, which is 1 over second. In the calculator, all right, this is where sometimes students have a problem, because depending on what calculator you're going to be using and how it wants you to do scientific notation is kind of important. And the reason is you have 3 times 10 to the 8 meters per second, which is a number. Then you have the division, which is an operation. And then you have 650 times 10 to the negative 9, which is a number. If I enter that into the calculator, 3 times 10, right, to the 8th, right, that's 300 million, divided by 650, but then if I hit the multiplication key, it'll take the speed of light and divide by 650, then it will multiply by 10 to the negative 9th. And we don't want to multiply by 10 to the negative 9th, we want 10 to the negative 9th divided by. All right, that's very important. So feel free to reach out to me. You can YouTube scientific notation in your calculator. Like, so if you have a TI-83 or TI-84 or whatever, Casio, whatever, if you YouTube how to use scientific notation in my calculator and give you your model, it will show you exactly how to do it. Do not Google it, because Google will take you to the Texas Instruments website, or used to, and tell you about scientific notation or something. Don't Google it. Go to YouTube and search your calculator model, putting numbers in scientific notation with my TI-84, and a bunch of videos show up and it knows exactly how to do this, so that you get the correct answer. And in this case, the correct answer, right, 2 sig figs is 4.6 times 10 to the 14th, 1 over seconds. Because again, when this -9, we're dividing, it's the same thing if we bring this up, right? Bring the 9 up and multiply, it'd be 8 and a 9. It becomes positive 9. All right? And so that's why we have a positive exponent. And that's very important. Now that's only halfway done. That's the first problem. That's the frequency. Now we've got the energy. E equals h nu. So our energy will equal Planck's constant, 6.626 times 10 to negative 34 joules times seconds, multiplied by 4.6 times 10 to the 14th, 1 over seconds. And we have 2 sig figs. So that gives me the energy of 3.0 times 10 to the negative 19 joules. Now, I'm going to pause again. I can be lazy with the calculator. I don't know if you can be or not. My calculator, if I just do the first calculation of frequency over here, I get more numbers in my calculator than 4.6. I just leave it there. And then I can just hit, because I'm taking that frequency and multiplying by Planck's constant, I take the frequency and I multiply it by Planck's constant, but I didn't round. So I might get a little bit different number here, right? That's technically not the best way to do things. I've been guilty of it many times. So you know, when I'm looking at things, I look at your work, right? That's why work is so important. And we'll look at that. So if the answer would have been if you got 3.1 down, but the answer was 3.0, well, to me, that's going to be the same thing, okay? It is a good habit, though, to get in the right or the correct amount of sig figs when we do these. All right. Let's look at the next one. An FM radio station broadcasts at 99.5 megahertz. That is hertz. So that means that's a frequency. All right, frequency. That's a 1 over seconds. And we want to calculate, there's our verb, calculate the wavelength. Calculate the wavelength of the waves. And so I want frequency and wavelength. I'm going to use C equals lambda times nu. And we're going to look for that one. And so we can divide both sides by nu. All right, so my wavelength will equal 3.00 times 10 to the 8th meters per second divided by 99.5. That capital M. Capital M. We'll have to look up what capital M is. That's mega. Got mega. And so this M is mega. And that's 10 to the 6. So times 10 to the 6. And that's 1 over seconds. And so if we do that, we get 3.02 meters. So that is our wavelength of that wave. Kind of nice. All right, now we're going to do the energy of a blue photon. So our question is, what is the energy of a blue photon? And it gives you 400 nanometers. And since the meters, that is a wavelength. All right, that's a wavelength. I'm going to use E equals hc over lambda. All right, just like if I scroll back up, right here, that one. E equals hc over lambda, because that's what's going to give us, make it one step. You can find the frequency first, So you could find frequency first and then the energy second. You could do that. I'm not going to do that though. I'm going to do it at the same time. So our energy would equal, all right, H, 6.626 times 10 to negative 34 joules times seconds. C, 3.00 times 10 to the 8th meters per second, divided by 400. And again, I got nanometers. That nanometer, 10 to the minus 9, 400 times 10 to the minus 9 meters. That's a horrible M. Let's try that again. There we go. E equals, if I do that to, I have 1 sig fig now, right? Because my number comes 4.9695 times 10 to the negative 19th. 1 sig fig, 5 times 10 to the negative 19th joules. Okay, next one. And this one is here because a couple things. First, I have 1, 2, 3, 4, 5. 5 sig figs. Right? Which is, I'm going to make sure my constants which in this case are H and C, for 5 sig figs. Do you have to memorize these constants to 5 sig figs? Absolutely not. You will always be given the constants to as many sig figs as those constants have. Now, some constants don't have but 2 or 3 sig figs, but these have more. These have a lot of sig figs, and you have access to all of those. Now, our formula, E equals HC over lambda. I need to rearrange that. Multiply both sides by lambda. All right. And so lambda E equals HC. Then divide both sides by E. All right. And so I get lambda equals HC over the energy. So now I switched. I'm looking for the wavelength, not the energy. I'm given the energy. All right. So now, constants. Planck's constant. Now I'm just going to write it all out here if you wanted to take note. 6.62606.931 times 10 to the negative 34 joules times seconds. Speed of light. 2.99792458 times 10 to the 8th meters per second. All right. Now listen, do we need to use all those sig figs? Of course not. I need to use 5. 1, 2, 3, 4, 5. So I'd have to put a 1 there where that 0 is for Planck's constant. And 1, 2, 3, 4, 5. And I would just do 2.9979. And that would be good. Okay. That I wouldn't need to type all those rests in my calculator. I'm putting them all here, and just in case you don't have them or they're access to them right now on your formula sheet or something, you have them. All right. And then the energy is 2.8397 times 10 to the negative 19 joules. And again, we're dividing by scientific notation. Make sure our calculator is giving us the numbers that are accurate. If you need help with that, again, YouTube, feel free to reach out to me. But I'm going to first tell you YouTube, like your calculator model, and go from there. Lambda I get is 6.9953 times 10 to the negative 7th meters, which happens to be the same thing as 699.53 times 10 to the negative 9th meters, which is 699.53 nanometers. However, your problem, that's perfect. Those are all 3 acceptable answers depending on what they ask you. Like they might ask you, what's the wavelength? Like, what is the wavelength of the red light in nanometers? Then they'd want it in nanometers. In this case, they just said the wavelength, and 6.9953 times 10 to the negative 7th is a wavelength. All right. What is the energy of an X-ray photon with a frequency of 1 times 10 to the 20th hertz? All right, so this one, all right, move the highlighter. What is the energy? And I have a frequency. Well, I think we just do E equals H nu. 6.626 times 10 to negative 34 joules times seconds, multiplied by 1 times 10 to the 20th, 1 over seconds, right? Because hertz is 1 over seconds. So our energy, it looks like that would be 6.626 times 10 to the negative 14th, which really, because I have 1 sig fig here, 7 times 10 to the negative 14th joules. Yeah, those sig figs, they're pesky. Important, right? Because about measurements. But they're pesky. Number 6 and 7. 2 more to do, and then we're done. How about that? What is the energy? Again, what is the energy? No, wrong color. What is the energy of a UV photon with a wavelength of 320 nanometers? All right. And again, anytime, I would feel free. Pause this video, try these two, and then if not, then watch, right? There's nothing wrong with that. It's actually great. So energy, wavelength, I'm going to do E equals HC over lambda. So H, 6.626 times 10 to negative 34 joules times seconds. Oh, 3.00 times 10 to the 8th meters per second. And again, I'm using 3 sig figs for my constant. My number only has 2. So I personally like to use more sig figs for my constants than the problem given, if possible. Not always is it possible. And your wavelength, 320 times 10 to negative 9 meters. So our energy is 6.2 times 10 to negative 19 joules. That's what I got. Finally, the last one. Same setup. E equals HC over lambda. All right, so E equals... All right, so what is the energy of UV photon? H, 6.626 times 10 to negative 34 joules times seconds. 3.00 times 10 to the 8th meters per second. And 250 times 10 to negative 9 meters. And one thing, if you need to do this, feel free. If you need to write H equals and C equals and put those numbers in, do it. All right, do not get discouraged. You do not have to go ridiculously fast. You got to go with some pace, but not ridiculously fast with these things. So this energy I got 8.0 times 10 to negative 19 joules. All right, so those are your energy, frequency, wavelength formulas and problems to do with energy and wavelength and frequency. I hope that helped. I hope it cleared things up. Make sure you do the practices. If you have any questions, do not hesitate to reach out, and